So my first bit of advice is to really pay attention as you write it down, and really as you're looking at it for the first time. Don't judge a book by its cover. Don't be like, oh, this is just going to be too horrible. But I mean, kind of just observe it as you're writing it down. So far, I've said x times e to the negative 2x. I know that e to the negative 2x right here will be a chain rule. But before I do that chain rule, I will have a product rule right here. But I'm not even done writing down the problem. Okay? Plus e to the x cubed. So no product rule right there, just chain rule. I do like to help myself out wherever I can. F G prime plus G F prime. So y prime will be x, because that's the first function, the derivative of e to the negative 2x. That is a chain rule. The inside is negative 2x. The outside is e. E to the something, okay? And the chain rule for e is super simple, but it's almost so simple that it doesn't make sense. Now, one thing that is a pretty common mistake in your head to be doing is think about x squared, right? Or x to the negative 2. While visually, with, bases and superscripts, we got some visual things going on that are similar, these two rules are completely different. First of all, this is a function within a function. This is just a variable to a power. This is just one function. And if I were taking the derivative of x to the negative 2, yeah, my derivative is negative 2x to the negative 3. But this derivative has absolutely nothing to do with e to the negative 2x. They're not related at all. Even though e has a power, you need to think back to what the derivative of e to the x is. The derivative of e to the x is e to the x. So when I'm taking the derivative of e to the negative 2x, all you do, you write down e to the something. In this case, it's to the negative 2x. So you write your inside back down. So whenever you're taking the derivative of e to the something, whenever your chain rule, the outside is e, you literally copy paste what the original was, and then you multiply by the derivative of the inside. The inside is this negative 2x right here. So the derivative of the inside is negative 2. So far I have written down, copy and pasted my f, which was x, and my g prime, which is either negative 2x times negative 2. And I'm going to actually go back and erase this. To finish out the product rule, I'm going to write a plus sign. Look, helping myself out, okay? G was e to the negative 2x, copy and paste it. And f prime, f is 1. Excuse me, f is x, so f prime is 1. So I have done my product rule. Now I'm going to actually take the derivative of e to the x cubed, which is another chain rule. So the outside is e, the inside is x cubed. I literally copy paste e to the x cubed and multiply by the derivative of the inside. So to clean this up a bit, And I'm going to leave it just like this. There's actually not a GCF. There is a base of E in every single part, but those bases of E do not have the same power. Now, normally when we have the same base, we take out the lowest power, and that's your GCF. But how can you take out a lowest power between negative 2x, and x cubed? Like, which one's smaller? You don't know because it's got a variable in it. So we're not going to take out an E. And this was from 3.6, part 2, number 29. So this problem, I actually have a student in front of me. I will not tell you who it is, but they want me to work it because it looks complicated. And at first glance, yes, it's ugly. You know, I wouldn't want to show this to someone who didn't know calculus and well, actually, I would want to show them because they'd think I was smart. But it's not bad, and you haven't seen it yet, so I'm gonna like really digest it as I'm writing it down. X squared minus 4x minus 4. Okay, I can take the derivative of that all day long. Okay, times e to the 7x over 4. And actually, it doesn't even have that parenthesis, so I'm not going to write it, but that's what it's saying. This is a product rule. Okay, where we have F right here, and we have G right here. And so we're just going to do I'm going to write down our formula, the F G prime plus G F prime, and I'm going to go ahead and start plugging it in. Y equals, okay, so F is literally copy and pasted, x squared minus 4x plus 4. G prime. This is the only part of the problem that is halfway complicated, but it's really not, because it's a chain rule. The inside is E, the outside is 7x over 4. You may want to think of that as 7 over 4x as the inside, okay? But anyway, to do this chain rule, the derivative of e to the x is e to the x. Well, this is e to the 7 over 4x. The derivative of the outside is e to the something, and you write that back down. You write the inside back down. So the first part of this chain rule for e, when e is the outside, you literally copy and paste the original down, and you multiply by the derivative of the inside. In this case, it's the derivative of that power e had. So the derivative of 7 over 4x is 7 over 4. Okay, so far, this is what I've done. The second function times the derivative of the first. Now, I will say that, look, I could go ahead and multiply this out and multiply that out. I think the first thing I'm going to do is take out an e to the 7 over 4x, because both sides have an e to the 7 over 4. And I'll have something plus something. So when I take that out, when I literally remove it, I'm left with x squared minus 4x plus 4 times 7 over 4. You know what I think I'm going to do? I think I'm going to go ahead and distribute 7 over 4 to the x squared and the 4x and the 4 as I write it down. Okay? So that would be 7 over 4 times x squared is 7 over 4x squared. 7 over 4 times negative 4x is negative 7x. And 7 over 4 times 4 is 7. Okay, on this side, I took out the e to the 7 over 4x, and I'm just left with 2x minus 4. Now, you notice I have these parentheses, but really they're not even needed. I wrote them there just to sort of have a place to put what was left, but now all I need to do is combine like terms. And I'm done. So I'm glad this came up. The student with me was like, whoa, that's not what Pearson says. And it's not what Pearson says. Pearson has this. And you know what? They're the same exact thing. Now, I like what I wrote better because mine is fully factored. Now, at first glance, these look super different. But if you'll notice, the only difference that Pearson has is that they didn't factor out the e. So if I distributed the e to the 7x over 4 back to everything in that trinomial, it's the same exact answer. So moral of the story, do not, you know what, let's say, okay, Dr. Morris, let's say you made a simple mistake. Let's say you put, I don't know, positive 5 right there, okay? And you're like, whoa, okay, it marked me wrong for this, and this is what they gave me. And you're like, I've lost my mind, I have no idea what I'm doing, and I'm going to fail. But you know what? That's not the case. That's not the case, because you just made a simple mistake. And your simple mistake, they threw something back at you that looked completely different to you, and you're just in freak out mode. My thing is, don't be in freak out mode. Don't be in freak out mode. Don't let anything scare you. And if you have a question about, is this the same or was I close? Let me know. And anyway, just don't freak out. Don't freak out. But no, the answer does not have a positive 5. It's a negative 5. So let me erase that. Okay. Okay, calculus. I was skimming through this, and we saw this problem, and we're like, whoa, can you work that? This is a very easy problem. In fact, all it is you got a product rule right here. Okay. And like your f is x squared, and your your g is x to the 5th plus 4 to the 7th. So that's going to require a chain rule. Let's go ahead and do f prime x to get 2x, and g prime x. So this is our chain rule. So the outside is something to the 7th. So 7 times something to the 6th. Write your inside back down. And your derivative of the inside is 5x to the 4th. Anyway, so I'm not actually going to plug that in. I'm just looking at this answer because looking at the answer, and this answer is for the second derivative, not the first derivative. But looking at the answer, yeah, this problem looks complicated. If you look at the original function, the y equals, it doesn't look that complicated, but looking at the answer, it looks horrible. And the thing is, I don't like this answer. This is not the way I teach you to write the answer. Because look at all these different parts. There's this, Johnny, let me undo something. There is this section, and there is this section, and there is this section. Okay? Everything has a GCF of x to the fifth plus 4. The lowest power of that I see a fifth power, I see a sixth power. So the lowest power I see is 5. Let's see, another, that may be the only GCF. But see, what I'm saying is, this answer is ugly. You're not used to me teaching you to do the answer like that, because I teach you to fully factor things as you go. And anyway, let's say that, the final answer that you get doing it my way, let's say it, first of all, it should accept it, okay? So if you've done the problem, you feel like you do it right, and it's wrong, okay? And this is the answer that it pops back at you. And you're like, whoa, what's going on? Send me your work. Send me your work. I will look at it, and chances are you may have made a simple mistake. Now, if you've done it and you know that you didn't make a simple mistake, but you have it the way I like it and it does not accept the answer the way I like it, let me know, okay? Let me know that. I want to know that, so that I can let the rest of the class know. But I am not teaching you to write the answer like this. I refuse. That's ugly. That's not fully factored. That's not useful to me. So just know the discrepancy there, and yes, that answer looks ugly because it's not simplified. So if there's an issue, if you feel like you've done it right, but that's not what the computer says, let me know. Send me a picture of the problem.